It's resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S. Chand Academy, official YouTube channel of S. Chand publication. Mathematics for IIT-JEE Main and Advanced by ML Khanna sir and videos by me Subuh Nadeem. So in this particular class we are going to do binomial theorem. In the previous lecture we did mathematical induction. So let us first overview the basic concepts of binomial theorem. A binomial term x plus y raised to the power n, where n is some whole number, is nc0 x to the power n plus nc1 x to the power n minus 1 y plus nc2 x to the power n minus 2 y square, and so on till ncn minus 1 x y to the power n minus 1 plus ncn y to the power n. This is the binomial expansion of x plus y to the power n. What are nc0, nc1, nc2? We already did this in permutation combination, what they stand for. In general, any NCR stands for n factorial upon n minus r factorial into r factorial. Further, is there some observation here? So yes, there is an observation here about the binomial coefficients. These are the binomial coefficients nc0, nc1, nc2 till ncn. What is that observation? If you see x plus y to the power 0, it is giving you x1. If you see x plus y to the power 1, it is giving you x plus y. If you take x plus y whole square, what are you getting is x square plus 2xy plus y square. These are we did earlier also without doing binomial theorem chapter. X plus y whole cube is x cube plus 3x square y plus 3xy square plus y cube. Similarly, we proceed for x plus y to the power 4, then x plus y to the power 5, till any natural number we take x plus y to the power. Now, what is the observation about the binomial coefficients here? That there is a formation of Pascal's triangle. So, there is a Pascal's triangle which is getting formed. What is that Pascal's triangle? First one, the binomial coefficient is 1. Next one, it is 1 and 1. Next one 1, 1 plus 1 2, then 1. Next one 1, 1 plus 2 3, 2 plus 1 3, then 1. Then next one 1, 1 plus 3 4, 3 plus 3 6, 3 plus 1 4, then 1. Now 1, 1 plus 4 5, 4 plus 6 10, 6 plus 4 10, 4 plus 1 5, then 1. This pattern continues. And if you observe, what are this? This is nc0, right? Or we say, instead of nc0, let us call it as, where n is equal to 0, this is 0c0. Now this one, the next one, here it is 1c0 and this is 1c1. This is 2c0, this is 2c1, this is 2c2. Here it is 3c0, this is 3c1, this is 3c2 and this is 3c3. NCN is always 1, NC0 is also 1. This is 4c0, this is 4c1, this is 4c2, this is 4c3, this is 4c4. Similarly, here also 5c0, 5c1, 5c2, 5c3, 5c4 and finally 5c5. So this pattern goes on continuing. So either you use binomial coefficients nc0, nc1, nc2 to understand it, or you can see the sum of these two, then sum of these two. But in Pascal's triangle, if it is asked for any nth row binomial coefficient, then you have to draw the whole diagram, which is a very lengthy process. For example, 29, then you have to make 29 rows to know the binomial coefficients. So instead of that, we use 29C0, 29C1, 29C2 till 29 C29. Now what are the other observations which we see here in the previous one? When you do the expansion, this is the main expansion upon which the whole chapter is based upon. So when you see this expansion, you see the number of terms. How many number of terms are there? So you can see that number of terms is one more than the index, that is n plus 1. From nc0 to ncn, it is n plus 1 terms. What else? X ki power n to x ki power 0. One by one it is decreasing. So power of x going from n to 0. So the power is n here, so it is from n to 0. Power of y, second term of the binomial. Bi means two terms. X is the first, y is the second. Y power is 0, then 1, then 2 till 1, n. 0 to n. And then what else we can observe? We can observe that the binomial, the power of the variables when add upon, they give n. So here also when you add up all the power of x and y, it is n. Here also when you add the power of x and y, it will be n. Here also y to the power 0 and x to the power n. When the power will be added, it is n. Similarly here, similarly here. So power of x and y on addition in any term is equal to n. So the index n remain as it is in each and every term. What other observation can you see here? If you see, many other observations may come up, but the important point is knowing the expansion here. Now we come to the general term. Again, keeping the expansion in mind, I am again writing the expansion here. X plus y to the power n, nc0, x to the power n, nc1, x to the power n minus 1, y, so on, ncn, y to the power n. Now here again, keeping the expansion in mind, if you see the general term as tr plus 1th term, this is called the general term. So the general term tr plus 1, where r can be 0 to n. So in that case, ncr, x to the power n minus r, y to the power r is the general term. For example, if you take r is equal to 0, you will get the first term, which will be nc0, x to the power n minus 0, y to the power 0, which is nc0, x to the power n. As you can see the first term here. If you see the second term, for which r is actually 1, so it will be nc1, x to the power n minus 1, y. Similarly, r is equal to 2, the third term is nc2, x to the power n minus 2, y square. And it keeps on going. R is equal to n, t n plus 1th term, which is the last term, as we know that the total terms are n plus 1. So it is ncn, x to the power n minus n, y to the power n, which is ncn, y to the power n, because x to the power 0 is 1. So as you can see here, this is the general term of binomial expansion, right? What else observation you can see here? So another observation which is here is middle term. If you want to see the middle term, then the middle term is t. Actually it depends that index is even or odd. So let us again write the expansion here, x plus y to the power n, nc0, x to the power n, plus nc1, x to the power n minus 1, y, plus nc2, x to the power n minus 2, y square, so on, ncn, y to the power n. Now here again, if you want to see the middle term, then the middle term will be if n is even, in that situation. So if n is even, n plus 1, which is the number of terms, will be odd number of terms. Now if there are odd number of terms, for example you take x plus y to the power 10. So number of terms will be nc0 x to the power 10 plus nc1 x to the power 9 y, so on, nc10 y to the power 10. Number of terms are 11. N is even, that is n plus 1, which is 11, is odd. Then the middle term is actually the sixth term. Sixth term is the middle term. And that term is 10c5 x to the power 5 y to the power 5. Because r you are taking as 5. If it is a sixth term, then r is actually 5. Because general term is r plus 1/8 term. So r is actually 1 less than r plus 1. So in general we can say that if we are talking about n even, then the middle term will be t n by 2 plus 1/8 term, that is nc n by 2 x to the power n by 2 y to the power n by 2. This is the middle term. If n is taken as even, if the power is even, then the middle term is n by 2 plus 1/8 term, and the binomial coefficient is nc n by 2, and the term is x to the power n by 2 into y to the power n by 2. Now if n is not even, we will come to the question right now. Let us see n is odd. So again you can proceed similarly, and you will come to the result that n plus 1 is even number of terms. Then there will be two middle terms. One term will be n plus 1 by 2th, another will be 1 plus 3 by 2th. When you take n plus 1 by 2th term, then nc n minus 1 by 2 will be here, x to the power n minus 1 by 2, y to the power n plus 1 by 2. So, or you say here plus, here minus, to be correct. Here minus, here plus. And the another middle term will be nc n plus 1 by 2 x to the power n, this was n minus r, oh sorry, so here it was plus 1, I didn't correct it, I have again wrote it as it is. So here it is n minus r, x to the power n minus r, and r is n minus 1 by 2, so this will be n plus 1 by 2, this will be n minus 1 by 2, and here n minus r will be n minus 1 by 2, y to the power r n plus 1 by 2. So there will be two middle terms when n will be odd, n plus 1 by 2 term and n plus 3 by 2th term, and their value will be like this, because here r will be n minus 1 by 2, 1 less than n plus 1 by 2, here r will be n plus 1 by 2, 1 less than n plus 3 by 2. Now let us come to few questions here. As you can see, in the first question it says, if the coefficients of 2r plus 1/8 term and r plus 2/8 term in the expansion of 1 plus x to the power 43 are equal, find r. So 1 plus x to the power 43 is the binomial term, and its binomial expansion will give you general term. So what about the coefficient of 2r plus 1/8 term of this? So 2r plus 1/8 term is actually having r as 2r, normally which we take r in theory, that is 2r here. So 43 c 2r, 1 to the power 43 minus 2r will be 1, x to the power 2r. And what about r plus 2th term? R plus 2th term will be 43 c r plus 1 x to the power r plus 1, right? Now it is saying that their coefficients are equal. So if their coefficients are equal, that means 43C2R is equal to 43CR plus 1, then how can we proceed? Now there is a very important formula we might have discussed earlier also, and you can see in the book also. NCR is actually equal to NCN minus R. This is a result, very important result. Or we also write it like this, that NCX is equal to NCY implies that X is equal to Y or X plus Y is equal to N. Okay, this is an important result based on the above formula. So based on that, because R plus N minus R is N, so X plus Y is N is another possibility, or X is equal to Y, which is quite trivial. So based on that, here 2R is equal to R plus 1, or 2R plus R plus 1 is equal to 43. This implies R is equal to 1 or 3R is equal to 42, which means R is equal to 14. So we have to find R. So we will say that R is either 1 or 14. This is our answer, right? Next term, next question. Find the coefficient of x to the power 5 in the expansion of this. Now this is not a binomial, this is a trinomial. How can you do a trinomial? So you can make it a binomial like this, that this is suppose x and this is suppose y. Now let us do the expansion. So 8C0 1 plus 3x to the power 8 and minus 2x cube to the power 0 plus 8C1 1 plus 3x to the power 7 into minus 2x cube to the power 1 plus 8C2 1 plus 3x to the power 6 minus 2x cube square, and so on. Now we need not know more than two terms here. Why? Because as you can observe that we need coefficient of x to the power 5. Okay, this is 5, index of x is 5, and here you are getting index of x is minimum 6, x cube square is already 6. So here the index is x cube square, which is giving minus 2x to the power 6, minus 2 to the power 2 into x to the power 6, right? So, and this will become plus after becoming a square, plus 2 square x to the power 6, and it will multiply with any of the binomial terms of 1 plus 3x to the power 6, its power will be minimum 6. So this term will not give you x to the power 5 coefficients, and further terms are greater in power, 2x cube to the power 3, then 2x cube to the power 4, they will be further more than x to the power 5, even more than x to the power 6. So further terms are not going to give you x to the power 5 coefficient. So our concern is basically this one and this one. So here 8C0 1 plus 8C1 3x plus 8C2 3x square, so on, and here is minus 2 into 8 16 x cube, and here it will become 1 plus 7C1 3x plus 7C2 3x square, so on. Now here we have to find coefficient of x to the power 5. So let us see where is x to the power 5 here. So x to the power 5 will come somewhere here, and there the term will be, initially it is 8C0 which is 1, and here it is x to the power 5 will be multiplied with 3 to the power 5, and 8C5 it will be there, binomial coefficient will be 8C5. So from this particular term 8C5 into 3 to the power 5 is actually the coefficient of x to the power 5. It is not binomial coefficient but coefficient. That means including any other constant also, not only NC0, NC1. So 3 to the power 5 is also included. Minus 16, it is x cube. So we need x square, which will come from here. So 16 into 7C2, which will be 21 into 9. So this will become 8 into 7 into 6. So by 6, 8, 7, 56. Now we have to do simple calculation, nothing else. So this will become 8, 7, 56 into 3 to the power 5. And here also you will get 8 into 7, I think. 8 from here, 7 from here, 56. And this will give 2. And this will give 6, 9, 6, 54. So this will be 2 into 3, 6, 9, 6, 54. So this will be 56 common. 3 to the power 5 is 243 minus 54 it will be. So this will be 56 into 243 minus 54, 43 is 200 and further 11, 189, right? Okay. Now 56 into 189, I will not do calculation always, but here I am doing the calculation part. For at least one question I am doing it. So 9, 6, 54, 5 carry, 9, 8, 6, 48, 5, 53, 5 carry, 6, 1, 6, 5, 11, 9, 5, 45, 4, 44, 4, 9. So 4, 8, 5, 1, 0. So this is coming out to be 10584. This will be your answer. If the option is given, you need not calculate till the end. It will be in some form of multiplication of composite numbers. Determine the value of x in the expansion x plus x to the power log x to the base 10 to the power 5 if the third term in the expansion is 1, 10, 100, 1000, 10,000, lakh, 10 lakh. So, what is the third term? So, r is actually 2 and this power is 5. This is 5 power. So, r is actually 2. So, 5c2 x to the power 3 x to the power log x to the base 10 to the power 2. And this is given as 1 with how many zeros? 6 zeros. And 5c2 is 10. 10x cube. And this is x to the power 2 log x to the base 10 is equal to 1, 2, 3, 4, 5, 6. 1 0 let us cancel. So x to the power 3 plus log of x square to the base 10. If we take 2 in the power, x square to the base 10, base x is same in both the places. This is 1, 0, 0, 0, 5 times 0. Let us take log to the base 10. So 3 plus 2 log x to the base 10. I am again taking this 2 in the multiplication. Log x to the base 10 for this x when we take log. And this is log of 1, 2, 3, 4, 5. So this is actually to the base 10. So this will be 5. So let us take log of x to the base 10 as z. Z is log of x to the base 10. So this is z, 2z square. This is z plus 3z. And from there minus 5 is equal to 0. Now let us do middle term splitting. So 2 into 5 will be 10. This will also be 5 minus 2. 2z square plus 5z minus 2z minus 5 equal to 0. This implies 2z is taken as common. So z plus 5. So 2z square. Sorry. Z plus not 2z is taken as common, z is taken as common. So this is 2z, that will give you 2z square plus 5. From the second one, minus 1 is taken common, is equal to 0. So z is equal to either 1 or minus 5 by 2. Now what is z? Z is log x to the base 10. So x is either 10 to the power 1, or you can say 10, or 10 to the power minus 5 by 2. So these are the two values of x which are possible in order to the question to be true. Let us come to the next question. 1 square C1, C1 means NC1, 2 square C2 means NC2, 3 square NC3, so on till n square NCn is n into n plus 1 into 2 to the power n minus 2. So when we come to this question, let us first write the expansion of 1 plus x to the power n, that is nc0 plus nc1x plus nc2x square till ncn x to the power n. Now how can we obtain this particular term? Let us think about it. So if you multiply with, instead of multiplying, you just differentiate with respect to x. First let us differentiate with respect to x. So it is n 1 plus x to the power n minus 1. This is nc1. This is 2 into nc2x. Then 3 into nc3x square, so on, plus n into ncn x to the power n minus 1. So on left hand side on differentiation we get this, on right hand side on differentiation with respect to x we get this. Now again multiply with x both the side. When we multiply with x both the side, this will be nx 1 plus x to the power n minus 1 is equal to nc1x plus 2 nc2x square plus 3 nc3x cube, so on till n ncn x to the power n. Now after getting this, let us again differentiate both the sides with respect to x. So here n is a constant, x differentiation is 1 plus x to the power n minus 1, and by product rule now nx will be taken as it is, n minus 1 plus x to the power n minus 2. Now this is equal to, on the right hand side, nc1 plus 2x, so 2 was already there, so 2 square nc2 x, then plus 3 square nc3 x square, so on n square ncn x to the power n minus 1. We have got this. Now we are getting somehow this term, and in order to perfectly make it like this, 1 square can be multiplied here, because multiplication with 1 square is simply by 1, which means nothing, same value. So 1 square nc1, right, 2 square nc2, 3 square nc3, so on n square ncn. So put x is equal to 1. When you will put x is equal to 1, left hand side will be n 2 to the power n minus 1 plus n into n minus 1 2 to the power n minus 2 is equal to 1 square nc1 plus 2 square nc2, because x is 1 now, so it will vanish, plus 3 square nc3, so on, plus n square ncn. Now this is what we had to calculate, right? And this is finally become equal to, you can take something common like 2 to the power n minus 2 is common, so n into 2 will be here, plus n square minus n, sorry, so this will become n square plus 2n, n will be common, n plus 2, n plus 1, n square plus n into 2 to the power n minus 2. So this will be your answer, n into n plus 1 into 2 to the power n minus 2, that we had to prove. So hence LHS of the question and RHS of the question are same. Find the sum of 3 into NC0 minus 8 into NC1 plus 13 into NC2 minus 18 into NC3 plus so on up to n plus 1 terms. So, if we want to calculate it, first try to analyze the general term. So, if you see the coefficients of NC are 3, 8, 13, 18 with plus minus. So, they are forming a series of like this 3 plus 5r into minus 1 to the power r. So, you can say that this is for r is equal to 0 simply 3. This is for r is equal to 1 minus 8. This is for r is equal to 2 13 with a plus sign. फिर minus 3 for r is equal to 3. This is minus and this is 18. And let us multiply them with NCR. This sigma of r is equal to 0 to n. This is what they are asking to calculate. Now, if you want to calculate it, you can write it like this: 3 common sigma of r is equal to 0 to n minus 1 to the power r NCR plus 5 r is equal to 0 to n r into NCR with, of course, minus 1 to the power r with it. So, let me write minus 1 to the power r also. Now, in this particular expansion, here r equal to 0, so NC0, then minus NC1 plus NC2 minus NC3 till minus 1 to the power n NCN. What this value is equal to? So, if you see the value of this summation, this value is going to be 0 because it is nothing. If you expand 1 minus x to the power n, expand it. Okay, I am leaving it to you. There are many questions, even theories based on this. You just expand it and put x is equal to 1 on LHS as well as RHS. So, on LHS you will get 0, 1 minus 1 is 0, and on RHS you will get this. Similarly, this, the second addition, this one, this is first term is 0 because r is 0, then second term will be minus 1 into 1 into NC1 plus 2 into NC2 minus 3 into NC3 so on plus minus 1 to the power n into n NCN. Now, this expansion is also 0. How can you come to that? So, again expand 1 minus x to the power n, and when you will expand 1 minus x to the power n, you will get the expansion as we know, NC0 minus NC1x plus NC2x square, so on. I am not writing the last term, you can write it. Now, let us differentiate. When you will differentiate, n into 1 minus x to the power n minus 1 into minus 1 is equal to minus NC1 plus 2 into NC2, then minus 3 into NC3, so on, and likewise. So, if you see with x, of course, 2 into NC2x, and then this is x square, so on. Now, if you see this, if you put x is equal to 1 again on the right hand side, what you will get is nothing but this thing on the right hand side, and on the left hand side it will become 0. So, this is also becoming 0. So, finally, this is also 0, this is also 0. So, 3 into 0 plus 5 into 0, overall answer will be 0, right. If CR stands for NCR, then the sum of the series, this one, where n is an even positive integer is equal to. So here it is saying if CR stands for NCR, which we already know, then the sum of the series, this one, where n is an even positive integer. In such a question where n is even, where n is odd, it is better to avoid confusion. Let us take n as 2m if it is even, and if it is odd, n as 2m plus 1. That will make the question easier. Not always keeping in mind that n is even, n is odd, just put it on the question. So when you solve, let n is written as 2m, where m is greater than equal to 1. So n is greater than equal to 2. It can be 2, 4, 6, 8, 10, 12, so on, depending m is 1, 2, 3, 4, 5, 6, so on. So n is equal to 2m, and now let us make the question like this, that 2 into m factorial into m factorial upon 2m factorial, and this is 2m c0 square minus 2 into 2m c1 square plus 3 into 2m c2 square minus dot 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 till the last term. I am not writing the last term, you can write it, is equal to minus 1 to the power m, n by 2 will be m, into n plus 2, which is 2m, 2 into m plus 1. Now here, in order to prove this statement, now forget about n. Now the question changes like this. If you prove this, in the next step you will say 2m is equal to n, so m is equal to n by 2, hence the result. Now here, this particular series, if you observe, what can be done about it? So 2m c0 square minus 2 into 2m c1 square, so binomial coefficients are getting squared. So in such situation, what we do, first let us take the expansion of 1 plus x to the power 2m. So this is 2m c0 plus 2m c1x plus 2m c2x square, so on. Then let us do one thing. Let us c1 multiply with x. So x into 1 plus x to the power 2m. So 2m c0x plus 2m c1 x square plus 2m c2 x cube, so on. Now let us differentiate. Here we have multiplied with x, now differentiate with respect to x. So x into 2m into 1 plus x to the power 2m minus 1 plus 1 plus x to the power 2m, and differentiation of x is 1. On the right hand side it will be 2m c0 plus 2 into 2m c1 plus 3 into 2m c2 x square, here it will be x also, and so on. Okay. Now not only this, let us, because we have come to some extent and there is a minus sign also, we will deal with that also. Instead of that, we should deal it with here only. Let us take it as minus, this also as minus, minus, this will be minus, this will be minus, and here this will be minus, this will be minus, this will be minus. So I am taking 1 minus x to the power 2m. So 2m c0 minus 2m c1x plus 2m c2x square plus minus x 1 minus x to the power 2m. So minus plus like this. On differentiation, x into 1 into 2m 1 minus x to the power 2m minus 1 into minus by chain rule, and here plus derivative of x is 1 minus x to the power 2m, and this is plus minus plus minus. Now you see, you are getting 2m c0 minus 2 into 2m c1 plus 3 into 2m c2, but here c0 square, c1 square, c2 square is there. So one more thing you have to do. Let us take the expansion of x plus 1 to the power 2m. This is another expansion. We took this expansion, we multiplied with x, then we differentiated it. Now let us take one more expansion of, instead of 1 plus x, x plus 1. So this will be 2m c0 x to the power 2m plus 2m c1 x to the power 2m minus 1 plus 2m c2 x to the power 2m minus 2, so on. Now this series and this series, I am highlighting them. This is a series, you can see its left hand side as well as its right hand side, and another series I am also highlighting, this one. So when you see these two series, if you multiply them, 2m c0 square will be the coefficient of x to the power 2m. 2m c1 square into minus 2 will be the coefficient of x to the power 2m again. This multiplied with this, x to the power 2m. This multiplied with this, x to the power 2m. This multiplied with this, x to the power 2m. And all the coefficients of x to the power 2m is nothing but this. So you can say that coefficient of x to the power 2m in the multiplication of the RHS of these is what is given in this bracket, which means that is equal to the left hand side multiplication also. So coefficient of x to the power 2m in the multiplication of this is 1 plus x to the power 2m, this one. This is 1 minus x to the power 2m. This is minus 2mx into 1 minus x to the power 2m minus 1. These type of questions are tough questions, but they will apply all the concepts that you have studied. So now coefficient of x to the power 2m in the multiplication of the left hand side is the same as on the right hand side. So in the next step, what is the coefficient of x to the power 2m? So here it is 1 minus x square to the power 2m. Here when you will multiply, so you can take minus 2mx into 1 plus x into 1 minus x square to the power 2m minus 1, right? You can write it like this. So coefficient of x to the power 2m in this expansion. Here in the first term, 2m cm will give you x to the power 2m into minus 1 to the power m. This is the coefficient of x to the power 2m, because if you take r as such way that it is x to the power 2 to the power m, then you will get x to the power 2m, and 2m cm into minus 1 to the power m will be the coefficient. Here if you take x and here 1, then it will be required x to the power 2m minus 1 coefficient, and you can't get x to the power 2m minus 1 coefficient because x square is there, so all the power of x are even, not odd. So this one will not give you anything. This one will not give you any coefficient of x to the power 2m, whereas this x when multiplied with this x will give you x square. So minus 2m and x square you have already got. What else you need is x to the power 2m minus 2. So if you want to get x to the power 2m minus 2, so you will write 2m minus 1 c, and 2m minus 2 will be obtained when you will get m minus 1 into minus 1 to the power m minus 1. There you will get x to the power 2m minus 2. So now let us summarize here. This is equal to minus 1 to the power from here also, and minus 1 to the power m minus 1 is minus 1 to the power m. So minus 1 to the power m common, 2m cm plus 2m plus 2m into 2m minus 1 cm minus 1. So plus 2m into 2m minus 1 Cm minus 1. This is how you will write it. So this is equal to minus 1 to the power m. 2m factorial will come out. 2m whole factorial will come out, because 2m into 2m minus 1 factorial will be 2m factorial. Upon m factorial here and m factorial here, it will also come out. What else will remain? 1 by m factorial here and 1 by m minus 1 factorial here. So this is minus 1 to the power m, 2m factorial upon m factorial, and when you take the LCM, it will be m factorial, and here it will be m plus 1. This is what we are getting. So now let us see how we need to put it. So if we put here 2m factorial into m factorial, and 2 is also coming from somewhere, I think. Let us see it later. So m factorial will get cancelled from here. 2m factorial will cancel from here, and you will get 2 into minus 1, 2 from here, minus 1 to the power m from here, into m plus 1. Now m is actually n by 2. M is n by 2. So 2 to the power minus 1 to the power n by 2, n by 2 plus 1. So 2 into minus 1 to the power n by 2, n plus 2 by 2. Now this 2 to cancel. So is this what we needed to get? Minus 1 to the power n by 2, n plus 2? Yes. This is what was obtained finally. So this will be our answer, right? So this is a lengthy question, but it is a good question. I hope you got this. Let us come to the next question here. Coefficient of x to the power 4 in x by 2 minus 3 by x square to the power 10 is. So general term, TR plus 1th term, 10 CR, x by 2 to the power 10 minus r into minus 3 by x square to the power r. So r plus 1th term is 10 CR, x by 2 to the power 10 minus r minus 3 by x square to the power r. Now x to the power 4. So let us simplify this. 10 CR, and this will be minus 3 to the power r upon 2 to the power 10 minus r, x to the power 10 minus r minus 2r, which will be actually 10 CR minus 3 to the power r, 2 to the power 10 minus r, x to the power 10 minus 3r. Now this 10 minus 3r is actually given as 4, x to the power 4 coefficient you need. So this implies that r is equal to 2. Now let us put it here and see the coefficient, not binomial coefficient but coefficient. The difference between binomial coefficient and coefficient. Binomial coefficient are only 10 C0, 10 C1, 10 C2. Coefficient means other than variable, any constant. So 10 C2 minus 3 to the power 2 upon 2 to the power 8. So this is 10 into 9 by 2, 45 into 9 upon 2 to the power 8, that is 256. 45 into 9, 9 5 45, 4 carry, 9 4 36, 4 40, 405 by 256. So which option? Option number A is the correct option, right? Next question says the term independent of x in this expansion is. So independent of x, again you take general term TR plus 1, which is root over x by 3 to the power, first let us take 10 CR, then root over x by 3 to the power 10 minus r, root over 3 by 2x square to the power r. This will become 10 CR root 3 to the power 10 minus r, and from here root over 3 by 2 to the power r. And what about x? X to the power 10 minus r by 2 from this first term, from this second term, minus r, as a square and square root will cancel. So finally independent of x. So it is only possible if this is 0. So if 10 minus 3r by 2 is equal to 0, this implies r is equal to 10 by 3 and r cannot be in fraction. So r is equal to 10 by 3 is not possible. So in that case, we will say that there is none of the term independent of x in this expansion, because there is no term independent of x. That is all for this lecture. We will meet again in the next lecture. Thank you.